Okay, welcome back. So in this lesson, we're going to walk through some problems. Okay, so I assume that you have watched the previous video about seeing the big picture already. Okay, so in this video we are going to go to the first two questions, and in the next video we are going to go to another two questions. Okay, so to see how do we tackle the real exam. Okay, the first question very short. Okay, determine the expectation of the range. Remember the range is what? The range is sample of size n, right? So it's gonna be what? The maximum of x1 up to xn minus the minimum x1 up to xn. There is a range, and each sample size come from what? Come from the uniform distribution in the interval 0 and 1. And we want to find the expectation because the range is a random variable, right? So we wanted to find the expectation that is the expectation of this one. So this is equal to 1. Okay? So if you're watching this video, please pause and try to do it first, okay? Before seeing the solution. Come back. So I assume that you have done this already. Okay, so let's go to the solution. Okay, this is fine. This is the first step. Okay, so do we wanted to find the joint distribution of these two variables? Yes, is no. Why? Because we can separate into these two terms, right? E of the max and E of the mean. Because we are not interested in the PDF, okay? But we are interested in only the expectation. Okay, so the PDF of the max is nx power n x n minus 1. This comes from the concept in chapter 3, the order statistic. If you could not remember this, please go to that topic. Okay, this order statistic. So the expectation of the maximum, we have times x, right, and we get this number. Similarly, for the minimum, we can get something like this. So we can get n1 minus x power n minus 1. And from the expectation, we can integrate. Okay, we can integrate to this one, and we get this one. Okay? And for this one, we can get what? Because, okay, the question is how to integrate this, right? Because we have x and 1 minus x, let's say like, oh my God, how do we do this? Okay, so the trick here is that if you don't want to do by part or whatsoever, I don't think by part works. Okay, so to cope with this one, let's say we put the n out, right? X this is what? We can get this one. X minus 1. Because minus 1, right? You have to find plus 1. That is the trick of plus 1 minus 1. Right? The question uses this trick. Okay. And this one is what? 0 up to 1 of 1 minus x n minus 1 ds. And we can get minus, right? We can get minus here. And we minus 1 minus x n ds. We can get these two terms. That's why we get C to these two terms. So in the real exam, we could not jump to this right? But But if some of you can, that's okay, right? But for me, I cannot. So because I do not come with the dream of all this number, I do not dream with the number. Okay, the way that I am going to deal with this problem, that is we use the trick of +1 and -1. Because we get -1 of this one, in order to group to be similar to that term, right? We get the trick of +1 and -1. And we can split from this one into the two easy term. Okay? And the rest of them is easy. It is 1 over n -1. Is the expression of range is this one. So after you get this answer, you may be reluctant to say that, oh, is my answer solution correct or not? So the one way is to do a sanity check. Okay? The sanity check is that you plug in the extreme value. Okay? So if n equal to 1, what should the range be? E of range should be 0, right? Do you get this one? 1 minus 1 over 1 plus 1 is 0? Yes. Okay. So let's see. If n is equal to infinity, and if we get infinite number, so the range must be 1, right? 1 minus 0. Do we get that? Go to what? Limit n minus 1 and n plus 1. It's going to be 1. So for the sanity check we pass, it doesn't guarantee that we get the correct answer. But if we found that is the wrong answer, you can be sure that is wrong. Okay? So the sanity check is the one filter test that let you see whether you have done it correctly or not. It is the first step. Okay? But if you wanted to, let's say, get full score, you maybe have to, let's say, check from the beginning to the end. But this one is just for correcting any mistakes. Okay, so if something mistake done during this integration step, so this one will be likely to show the error. Okay. The second question: suppose that the joint distribution of x and y is uniform distribution over a rectangle with side parallel to the coordinate axis in the xy plane. Determine the coordination of x and y. Okay. So it's gonna be something like this. We have the x, for example, okay? We have the x and we have the y. Let's say distribution over coordinate. Let's say we get small y, small x, any number, and we get a uniform distribution. That is here we get f x y is what? Is 1 over x times y. That is, if we sum over this idea, we get 1. Okay. So the question is, what is the correlation of x and y? We have to determine the correlation. Okay. So please pause the video and do it on your own first before proceeding to watch the solution. Okay, come back. So I assume that you have, let's say, watched, you have, let's say, done this question. Okay. So intuitively, if I ask you, let's say, you have to give me 5 seconds to answer this question, what do you answer? 0, right? The correlation should be 0. Why? Because it is the uniform distribution. That is, let's say, okay, suppose that we get 1 and 1, right, for simplicity. Let's say we say that x equal to 0.5. Does it make any better guess of y? Let's say firstly we guess, let's say y equal to 0.5. Okay, that's the mean. But let's say that x is equal to, let's say, 0.2. If x is equal to 0.2, so do we change any guesses? Unlikely. Why we will not check any guesses by seeing the X. So the correlation must be zero because there are no relationship between the two observers. That is the intuition that we have to get. We have to visualize this one first before jumping into the calculation, because in the calculation, everything is number. Okay, so we are not sure that this makes sense or not. So it makes sense to draw the diagram and guess the solution first. Okay, but we have to go to the math anyway. Suppose that the support of x is from 0 to x0, y from y to y0. We get the e of x, e of y, and we find e of xy. And we see what? The covariance is going to be what? 0. So the correlation must be 0 as guessed. Okay, so we have seen the two questions already. And in the next video, we are going to go to the third and the fourth question. Surely it must be a little bit more challenging than the first two. Okay, so good luck and see you next time.